Look, it's awful to be asked to inspire people. It's the worst brief a speaker can get. And so what I want to talk to you about is something that inspired me very recently in the hope that it will rub off on at least some of you. This time last week, I was just recovering from having sat up overnight in this place. This is Mission Control at Darmstadt, Germany, in a place called ESOC, the European Space Operations Center. And this is the room from which this team of controllers, led by a woman incidentally, controlled the Philae lander, which had touched down on the surface of Comet Churyumov-Gerasimenko, which I'm looking forward to never having to say ever again. I was there last Saturday night, just a few of us, watching as they received the last signals from Philae, which had run out of battery life after 58 hours on the surface. And Philae is nothing more than a machine. It's about the size of a small refrigerator, a hotel minibar if you prefer, and it was a robot. It carried out its commands as programmed, it deployed its instruments, it sent back what data it could, and in some ways has no more personality than my malfunctioning computer at the front here. And yet it was impossible that evening not to feel the emotion in the room as the engineers and scientists watched its battery life drain away. And we realized that we would probably never hear from the thing again. It was actually upsetting, and tears were shed, not just by the team, but by those of us who were watching. And so you'd think that the scientists who were deeply involved with Philae, who were gathered just up the road at their own control facility, would have been equally upset as their probe died a slow and cold death. But actually, what they were doing was breaking out the champagne. In fact, they had champagne prepared. It's Comet wine, which is a long tradition going back to the 19th century. And they were ecstatic. These people, even as the last signals were received, were popping champagne corks and celebrating, and they looked incredibly happy. And to understand why that was inspired me, because these people had faced a remarkable journey. The first ideas that led to Rosetta, the probe that dropped Philae off, and Philae, were proposed in the early 1990s. The probe has been in space since 2004, and they'd waited, some of these people, their entire careers for the moment when touchdown would occur. And the probe had had some challenges. This is one of my favorite pictures from the mission. This is a space selfie, which we're allowed to call it. This is a picture from Philae of its mothership Rosetta. And in the background, you can see Comet Churyumov-Gerasimenko. It's twice. I'm going to try and get it in 3 times. And you can see that it's an interesting world. If we zoom in, we see this now famous sort of rubber duck shape. It's slightly like a boot to me, I think. But the problem with this is that this is incredibly exciting, that this the center of this comet, just a few kilometers across, has this interesting shape. But the mission team had assumed that this thing would be round. And a nice round body can be easily modeled, and you can work out the gravity that's going to pull in Philae, which after all didn't have any rockets, it just dropped. And if you have a nice round surface, then it's A-level physics, and you can work it out. When you have something like this, things are much more complicated. And as the team got a close-up view over the last few months of this comet, they discovered that things were even worse than they expected. This is a picture of their targeted landing site. And we expected not only for the comet as a whole to be round, but for this to be a smooth surface so that Philae could touch down and put its legs down and be perfectly stable. This is not a smooth surface. There's very little there that you want to land on. There are even what look like boulders on the surface. And in fact, what was really interesting was that the team had determined that this comet was the blackest object that we've ever seen. So in these pictures, it looks a sort of nice grey colour. It's actually much blacker than a lump of coal. And actually, we don't understand why it's so dark. But one reason might be that the centre is sort of amorphous, sort of think like the texture of sand or cigarette ash, so that the light would sort of get trapped in it. And if that was true, then you can imagine Philae just sinking into this soft surface and disappearing from view. So the landing itself seemed perilous, it seemed scary, even as the craft was released from the lander. Now, the gravity at this comet is incredibly weak. The thing is very small, and if I walk at this speed on the surface of the comet, I will escape into space. And so even though Philae was released from about 10 kilometers above the surface, it took 7 hours to drop towards the surface. And then another 2 hours to return a signal. another 28 minutes to return a signal to us. And I can tell you what it felt like for me when that signal arrived and Philae said, yes, I'm on the surface. Actually, I don't have to tell you, I can show you what it looked like for me. This is what happens when you do a comet landing on television. There's Maggie, who's already been mentioned. And at this moment, we thought all was well. This is the champagne moment. This is the thing has worked, the engineering has worked. We have touchdown on the comet for the first time in human history. But it soon became apparent that things weren't as they seemed. At this point, the mission team thought that the lander was safely on the surface. It was supposed to, of all things, have deployed harpoons and hung on to the surface with its harpoons. But it became apparent very shortly after this picture was taken that Philae was spinning. And you don't have to be a scientist to realize that if you think you're fixed on the surface and your instruments are telling you that you're spinning and something has gone horribly wrong. And in fact, Philae had bounced. And because of the low gravity on the comet, it conducted a 2-hour bounce, reaching 1 kilometer up into the air and hitting 80% of that speed that's required to escape. So it very nearly bounced off into space. Just the other day, we found pictures of this. So here we are. You can see little Philae here, and these are successive times. So this is it coming in, taken from Rosetta. It touched down here, and then here's the fatal image that shows that it bounced off. And in fact, we still don't know where the thing is. Scientists are still analyzing the data. But after 2 hours, it touched down, and then and then it bounced again, and 7 minutes later, it came to rest. And I love the fact the team were very enthusiastic about this. The thing survived those 2 bounces, and so they announced proudly a few hours later that they'd landed on a comet not once, but 3 times. And then we started to get pictures back. So this was the first picture we saw from the surface of the comet. This is actually the foot of Philae, and you can see this very rough, dark surface of exactly the type that we were worried about. And it became apparent that all was not perfect with Philae. It had landed not on a nice flat plane, but in a hole. After a 6 billion mile journey, it's ended up in a hole. And in fact, it's ended up against a wall with one leg up in the air, something like this. And I think the most incredible thing about this mission is that it did all of that. It bounced and it landed up on its side and it operated almost perfectly. It was designed to carry out all of its science within the first 60 hours on the surface. And this is the answer to why the team was celebrating. They knew that this was a risky mission. They took the risk anyway. They bet 20 years of their career on it. But they took the risk and they decided to go for this and decide that they would do everything they could within the first 60 hours because that's the time that the batteries should last. Philae has solar panels. We'd hoped that if it had landed out in the open, those would recharge the batteries. They may still do so. But it was designed to deploy all its instruments within 60 hours. And we already, a week later, have science from these instruments. And that's what I want to tell you about. Sometimes science is complicated. We've had that demonstrated already. But sometimes science is very simple. And the best experiments are almost always simple. So take, for example, an experiment on Philae called MUPUS. I can't remember what MUPUS stands for, but you can see it in this diagram. It's this purple thing that looks a bit like a hammer. And that's exactly what it is. MUPUS was designed to prod the surface because we didn't know how hard the surface of a comet is. If we want to understand these things, it seems a fundamental property to understand how hard it is. And MUPUS has already delivered the definitive result, and that is that comets are harder than we expected. MUPUS had 3 modes. Mode 1 was sort of a little tap. Nothing happened. Mode 2 was a bit of more of a tap. Mode 3 was more of a tap again, and all 3 bounced off the surface. Turns out the engineers had a secret mode, which they called, originally enough, Mode 4. Mode 4 was a proper whack, and the hammer broke off the spacecraft. And so we have a definitive result to a scientific experiment. The comet is quite hard. And that doesn't make, but what's exciting about that is that that doesn't make any sense. Not only is it unexpected, we thought that this thing should be fluffy. Remember, that's the explanation for why it was dark. It was this sandy cigarette ash type structure. So this result makes no sense, but at least it's a clean experiment. I suppose you could argue that this comet in this place is hard, but let's extrapolate. Other experiments have returned data too. If you look at Philae, this is a picture of Philae as it was descending. I love this picture, taken from Rosetta. You can see the 3 legs outstretched, ready to bounce. This is not a recommended trampolining pose. But you can also see these 2 things here, and these are antennas, or antennae, I suppose, from an experiment called CONCERT. And CONCERT was a brilliant experiment. It sent signals from Philae through the comet back to the mothership. And what that does is it allows us to work out what the interior of this comet is like. Just as scientists use earthquakes to study the internal structure of the Earth, we can use these signals to work out what the internal structure of the comet Cheremeyev-Gerasimenko 3 is actually like. And we'll soon know, by the way, whether this shape is because these are 2 things that have stuck together, or whether this is one body with an interesting history. CONCERT will tell us that. It's also the thing that will help us identify where Philae is. So we also have results from this sort of sounding experiment. But the most exciting result is a little bit abstract. It's from a couple of instruments, one of them British-led, although all of the instruments on board are international, and it involves, you'll be pleased to know, hydrogen atoms. So I promise we didn't plan this. So a typical hydrogen atom has a proton in the center, as you've heard, and an electron. But sometimes we have heavy hydrogen. It's called deuterium, and it has not just a proton, but a neutron at the center. And the ratio of hydrogen to deuterium in the universe was set right at the beginning, 13.8 billion years ago. And then it gets changed depending on what's happened to stuff since then. And there is this theory that all of the water on Earth comes from comets. Now that always sounds ridiculous, I get that. It sounds ridiculous because you sort of always think of Earth as being wet, with a blue planet, for goodness sake. Why do we have to have our water come from anywhere? But the early Earth, when it formed, was hot. And any water that existed on or near the surface of the early Earth will have boiled away. And then we've got to get the water back so that we can have the nice rainy skies that we see today. And one solution to this is to have a comet hit the Earth every 300 years for a few million years. And if you do that, then you can quickly build up enough water to fill all the oceans on the Earth. And so to test this, what we can do is we can go and take a glass of water from Earth, and we can look at the ratio of deuterium, the heavy hydrogen, to normal hydrogen in water on Earth. And then we go to a comet. We land a chemistry lab on the comet. We've just established that's harder than it seems, but nonetheless, that's what they did. And you can sample this, and we can get this result. And we discovered, this was announced yesterday, that the ratio of heavy hydrogen to normal hydrogen on Earth is nothing like the ratio on the comet. And so we know now what we didn't know a week ago, which was that this explanation is nonsense. So comets did not supply water on Earth, and we have to look for other explanations. We're tending to look at a large number of asteroids hitting the Earth, or there's a heretical group of people who believe that the water didn't boil off the Earth, but actually hid deep in the Earth's structure and then came back to the surface. So I don't know where that argument will end, but the point is that because this thing bounced and landed and sampled and tasted and sniffed the comet, we found something that wasn't true. It's a fabulous scientific result, and just as important as a result that's actually true. I think particularly in school, we give the impression occasionally that science is about getting right answers, but actually exciting science is about getting wrong answers. The exciting stuff is when something doesn't make sense. And this was a neat explanation to the problem of Earth's water that we've now ruled out. So what's going to happen to Philae? There are loads more results to come. There'll be years of papers and arguments about all sorts of things. I'm particularly interested in whether the comet has a magnetic field, a result which will tell us about how planets form. But in the more immediate future, there's been a lot of talk in the press of Philae maybe waking up and phoning home. It's true that it was designed to have its batteries run completely dry and then charge with these solar panels. And if something happens and the hole is exposed to sunlight for some reason, maybe because of the activity on the comet, then we will hear from Philae again. But in the meantime, the comet is waking up. And we have this Rosetta spacecraft in orbit around it for the next 18 months, which will take amazing, incredible pictures like this one. And we'll watch as the surface of the comet transforms from a very benign-looking duck to a place of wonder and mystery with jets and material and a melting surface. And we'll watch this for the first time in human history. It's hugely inspiring to me, but here's the thing. We went to Rosetta because a group of people dedicated 25 years of their lives to saying we should go to a comet and we should do these experiments. Europe went to a comet because we decided this was something we could do. We could do better than anyone else, including NASA and those Americans. So here's the question. Will we go back to a comet? Will we launch a probe to something with a more pronounceable name in 20, 25 years' time? Well, that decision will be made, not by me, not by my colleagues, but by some of the people who are sitting in the room now, because this is what your careers could be. But for goodness sake, don't pick one discovered by Russians. Thank you very much.